Hey guys, Mr. Betts here. I want to look at a little bit more of a challenging problem using substitution. And this one's going to require a little bit of a trick that you won't see very often, but it is something that could come up, and I want to talk about how we would handle it. So in this problem, we've got a situation where we have two different expressions that would be good candidates for choosing for u. And neither one of them is going to simplify the expression enough to actually take the antiderivative. So what I'm going to do is I'm going to look at the more complex part, which is the square root part, and I'm going to work on simplifying that. So I'm going to choose my u to be 3x plus 1. So that square root is just going to be u to the 1 half. That gives us du equals 3 dx. Okay, so that's going to give us dx is du over 3. So let's make the substitution part that we can here. So we have the antiderivative of 90x plus 57 times u to the 1 half, and then it's going to be times du over 3. Now, the only really simplifying I can do within that is going to be dividing by 3. And actually, I can just divide each of these by 3, term by term. So dividing the whole expression by 3 is the same thing as distributing the 1/3 in those parentheses there. So this is the same thing as the antiderivative of 30x plus 19 times u to the 1 half du. Now, the problem we have is if we're taking the antiderivative with respect to u, this entire integrand has to be in terms of u in order to do that. If we had constants, we could factor those out of the integral, take those out front, but this 30x here is not a constant, so we can't do that. So what we're going to do here with the substitution choice that we made here is we're going to solve for x. So x here is going to be u minus 1 over 3. And so using the same substitution, or at least the same equation that I used for the substitution, I can replace the x with u minus 1 over 3 to complete the substitution. So doing that, we're going to have 30 times u minus 1 over 3 plus 19 times u to the 1 half du. So then we can do a little simplifying there. That's going to give us 10. So we get antiderivative of 10u minus 10 times u to the 1 half du. And that we can actually distribute. So we can rewrite that as the antiderivative of 10u to the 3 halves minus 10u to the 1 half with respect to u. Now I can integrate both of those. Oh, I forgot my 19, didn't I? I need a plus 19 in here. So plus 19 needs to go in here, which is going to make this a plus 9, which is going to make this a plus 9. Okay, now we can take the antiderivative at this point using the power rule on each term. So we're going to have u to the 5 halves, and then 2/5 out front times 10, plus, got the 9 there, it's going to be u to the 3 halves times 2/3. And then when we take the antiderivative, make sure you remember the plus c. And we can do some simplifying with that. So we're going to get a 4 in the coefficient here. We're going to get a 6 in the coefficient here. And when we have an indefinite integral, remember we need to rewrite this back in terms of x. So our final answer here is going to be 4 times 3x plus 1 to the 5 halves plus 6 times 3x plus 1 to the 3 halves plus c. Now, we could take this whole process that we just did here and do that with a definite integral also. I'm not going to go through those steps, but the idea is going to be the same. We just have to remember that when we change the dx to a du, then our limits here are also going to change, but otherwise the process is going to be the same. And once we get our antiderivative in terms of u, we can use our new limits of u to evaluate that. If you're looking for some practice with this, with a little bit more of a challenging problem, feel free to give this one a try. I am personally not going to do it myself. You can do it and then check your answer by plugging that into your calculator and see if you get a matching answer.